What we're going to do in this video is motivate the idea of a mathematical relationship between two quantities. In our everyday lives, we often see how one thing depends on another. For example, your grade on an exam depends on your actual score, or the area of a circle depends on its radius. In mathematics, we call this general idea of pairing things a relation, which is simply a set of ordered pairs that relate elements from one set to elements of another set. But the big question we want to answer is, what makes a function different from an ordinary relation? By the end of this walkthrough, you'll see that while every function is a relation, not every relation is a function. Now, I have a few pairings written here, a student paired with their birth date and a student paired with their favorite color. Before we dive into the math, I encourage you to pause the video and think about which of these rules allows for one person to have more than one result, and which one only allows for exactly one. Alright, let's think about this together. A relation is any collection of ordered pairs A, B, where A is from set A and B is from set B. However, a function is a special, well-behaved relation in which each input corresponds to exactly one output. Let's look at the examples displayed here on the screen. All of these ordered pairs are relations, because to be considered a relation, they simply need to be ordered pairs. The main question in this topic is what characteristics of a relation make it a function, or in other words, what type of relation is a function? As we said earlier, a function is a type of relation in which each input corresponds to only one output. Let's examine the ordered pairs shown in the examples one by one. The first relation is the set of students paired with their birth dates. Alice is born on January 12, 2004, Ben is born on March 8, 2003, and so on. This relation is a function because each student, which is the input in this case, has exactly one birth date as the output. In other words, no student in this relation has more than one birth date. Therefore, the relation of students paired with their birth dates is indeed a function. The second relation is the set of students paired with their favorite colors. Here, Alice happens to have two favorite colors, blue and purple, and the color blue happens to be the favorite color of both Alice and Clara. The fact that blue is the output for more than one input does not prevent the relation from being a function. As an example, the third relation here is in fact a function even though blue is repeated as an output. A function allows multiple inputs to share the same output, but the problem for the second relation is that Alice, a single input, is paired with two different outputs. Since one input has more than one output, this relation is not a function. Before we move on to identifying whether a relation is a function, let's first become familiar with the concepts of domain, codomain, and range. The domain is the set of all inputs of a relation or a function. Let's use our first example for illustration. In this relation, or function, the domain is the set of student names: Alice, Ben, Clara, David, since these are the inputs. Now let's move on to the codomain and the range. You can think of these similarly to the relationship between a set and its universal set. The codomain is the set of all possible outputs of a relation or function. In our example, the outputs are birth dates, so the codomain would be all possible dates on which a student could be born. The range, on the other hand, is the set of the actual outputs produced by the relation or function. In our example, the range consists of the 4 birth dates that correspond to the students in the domain, as shown here. We'll revisit each of these sets in our upcoming examples so that we understand them completely. Alright, now that we've seen what a function is and what differentiates it from a general relation, let's look at how to determine whether a relation is a function. The reason we're discussing this is that not every relation is expressed as an ordered pair like the examples we've seen so far. The first case is when a relation is expressed as ordered pairs, or in tabular form. In this case, we simply check whether the same input is paired with different outputs. If we find a repeated input with different outputs, then the relation is not a function. On the relation R, each input is paired with one output, or no domain member is paired with more than one range member. Therefore, it is a function. On the next relation, relation S, 1 is repeated, meaning 1 is paired with 2 and 3. Therefore, it is not a function. Notice that it's perfectly acceptable for members of the range to be repeated. However, members of the domain must not be paired with different outputs, as shown on the screen. The second case is when the relation is expressed as a mapping, where elements of the domain are connected to elements of the range by arrows, as shown. If at least one element of the domain has more than one arrow pointing to different elements of the range, then the relation is not a function, illustrated here. However, if every element of the domain has exactly one arrow pointed to an element of the codomain, then the relation is a function, as illustrated on the screen. Notice that there are some unpaired elements in set D. For that reason, set D is the codomain, but not the range, as we discussed earlier. To be included in the range, an element must actually be paired with an element from the domain. Therefore, the range consists only of the paired elements, as shown. All elements in set B except 6. The final case is when the relation is expressed as an equation or a graph. When the relation is given as an equation, we check whether a single value of x can produce more than one value of y. If that is possible, then the equation does not represent a function. Let's look at a linear and a nonlinear example.
The first equation is y equals 3x plus 2. Since each value of x is multiplied by 3 and then increased by 2, let's see the equation in an order pair. When x is 0, y is 2. When x is 1, y is 5. When x is 2, y is 8, and so on. Hence, every value of x produces exactly one value of y. Therefore, this equation represents a function.
The second example is y squared equals x. This can be expressed as y equals to plus or minus square root of x. Here, a single value of x can correspond to both the positive and negative values of y. Let's take x equals 9, for example. When x equals 9, the equation becomes y squared equals 9, which gives y equals 3 and y equals negative 3.
Since one input produces two different outputs, or as we can see, member of the domain being repeated on the set of ordered pairs, this relation is not a function. We can verify this using the graph as well. When a relation is expressed as a graph, we use a method called the vertical line test. The idea is simple. Imagine drawing a vertical line anywhere on the graph. If the vertical line intersects the graph at any point at most once, then the graph represents a function. If there is any position where the vertical line intersects the graph at more than one point, then the relation is not a function. Let's first look at the graph of y equals 3x plus 2. As we move the vertical line along the x-axis, it intersects the graph at only one point each time. Therefore, this graph represents a function. Now, let's look at the graph of y squared equals x. As shown, when we draw a vertical line through certain values of x, the line intersects the graph at 2 points. This means that a single value of x corresponds to two different values of y, which violates the definition of a function. Therefore, this graph does not represent a function. To wrap up, relations are just pairings, but functions are the single output stars of the math world. We've covered how to identify them through ordered pairs and the vertical line test. And we're done. Hopefully that makes some sense and gives you a strong foundation for our next lesson, where we'll start graphing these functions and looking at different families like polynomials and exponentials. If this walkthrough was helpful, hit that subscribe button to keep mastering math with us here at Rimetric Walkthrough. Thanks for watching, and see ya!